At the beginning of topic 2, we're going to look back at parabolas, which we already looked at in topic 1, but here we're going to formalize it because this chapter is about quadratics. In quadratics, the graph of quadratics are parabolas. So we're going to tie in some more vocabulary and detail to it. So let's first of all add to our notes here. Our objective is to be able to graph parabolas in vertex form. Let's go ahead and add to this our line underneath topic and detail for our notes. Right, now to give the formula, this formula will look familiar because we did translations of the family of quadratic graphs. We looked at the parabolas moving side to side and up and down and stretched them up and stretched them wide. So this formula that we're going to use will be able to formalize all the detail on that. So we're going to have y equals a times x minus h, the quantity squared, plus k. Now we know all of these pieces from before. We know that the number in front is what stretched it up or stretched it wide, and also if it's negative it flipped it over. The h and the k, remember we always did the inside number was always the opposite, so that's why you have x minus h here, and the number outside was the up and down translation, and that was exactly the same as the way it was originally. So when we look at this, the vertex is going to be h comma k. So it's going to be whatever value is the opposite in there and then the same out there. So this vertex here on this graph will put h comma k. That's the ordered pair for it. Now, in order to find the min or max of this graph, we have to know whether it opens up or down. So remember, if the a is positive, this number in front, a is positive, then it opens up. If a is negative, then it opens down. So if we have it opening up, like this one does, we have a lowest point, a minimum. So opening up, we have a minimum. And the minimum value is that y value at the vertex. Minimum at y equals k. Now if it opens down, if this were to flip over, because we have a negative a, then we'd have a maximum. There'd be a top point, and the maximum would be at the point, at the value, the y value there, y equals k. So the y value at the vertex is always the minimum or the maximum for the parabola. If it opens up, it's a minimum. If it opens down, it's a maximum point. All right, now the next part, we want to find the y-intercept on this graph. So that's going to be something that we'll use typically in doing our graphs. So to find the y-intercept, you want to substitute x equals 0 in and find y. So like in this equation down here, you put in x equals 0, and then you'd find y by doing 0 plus 1 is 1, 1 squared is 1, times 3 is 3, 3 minus 4 would be a negative 1. Would just be substituting in and finding the value. All right, now the next part, this is a new phrase, this is a new term, it's shown right here on the graph. It's called the axis of symmetry. The axis of symmetry is like the folding line. The I'll put this in quotes to give you the idea of what it is. The folding line, meaning that if you were to fold on this line, this half of the parabola would fold right on top of the other half. So how you find the axis of symmetry is you want to think of it as the vertical line through the vertex. This is the vertical line through the vertex. Okay, notice that's that dotted line right there. It's just dotted there to show that it's a folding line. That's the first thing we need to know. And the second thing to know is that because it's a vertical line, it's going to be x equals that x value at the vertex. X is going to equal h, is the AOS, axis of symmetry, equation. So just to abbreviate, we'll use this AOS for axis of symmetry. And so the x equals the h value is the axis of symmetry. Y equals k is going to be either the minimum or the maximum, depending on whether it opens up or down. All right, let's take a look at this graph then. We'll try this one first. Okay, now looking at this graph, we're going to use this information and list it. So first of all, let's just start listing the information here for the graph. So let's list the vertex. Remember, the vertex is the value here that we're going to have that is going to be the opposite of that number inside and the number on the outside. So -1, -4 is your vertex. Now when I set up a table, if you recall, we're going to put the vertex right in the middle of it. -1, -4 goes right in the middle of the table. This is the vertex. Let's go ahead and plot that point. -1, -4, 1, 2, 3, 4. Right there. All right, now let's go ahead and list some of the other information. Next, we'll list the axis of symmetry. AOS for axis of symmetry. That's just x equals the x value at the vertex. So you just give that equation. Let's do the. Let's go ahead and do the figure out how it opens and if we have a min or max. Because the number in the front is positive, it's going to open up. And so if it opens up, that point is going to be the bottom point, so it's going to be a minimum at y equals -4. I haven't even graphed it, and I already know that that's the lowest point on the graph because of how these work out. Okay, and lastly, let's do the y-intercept. The y-intercept, you put in x equals 0, and you get out, when you put in x equals 0, 1 squared is 1, times 3 is 3, 3 minus 4 is -1. So we're going to have the point here, we're going to have 0, -1. Okay, so that will be right here. That's my y-intercept. Now we know the symmetry involved in this. Remember, if there's a point on this side, there's always a point on the other side of the vertex. So we know there's going to be another point here. Even without looking at the equation, there's going to be one at -2, -1. Let's go ahead and check that out on our graphing calculator. So let's put the values into the graphing calculator here. Clear this off. We'll put in our equation. We'll clear off what we have previously here. And now we'll put in 3 times parentheses x plus 1, parentheses, we're going to square that, and then have -4. Then we can look at the graph. So this is our standard graph for it. Notice there's our vertex. There's a couple points around it. Let's get some more. And we look at the table to do that. Notice we got all this information without even looking at the table. So let's look at the table. Notice -1, -4, -2, -1. We've got those values. Let's do -3 and 8. And we should have on the other side here, the other point next to it has that symmetry. We should have an 8 there. Let's check out our table to make sure. Sure enough, 1 goes with 8 as well. So let's plot those two. And so we've got 1 comma 1, 2, 3, 4, 5, 6, 7, 8. So right up here. And then on the other side, we have this point here for our graph. Okay. So our parabola is thin because this 3 has stretched it up. And then we had our vertex at -1, -4. So notice that we got all this detail now that we want to start listing for our different equations for our parabolas. Now we're going to try, before we do some examples, we're going to do one more new idea. This is when we find the equation of a parabola, of the quadratic, given this information. So what I want you to notice here is that they give us the vertex. That's what we want to do first. So in our general form for a quadratic, looks like this. So where we can put that 5 and that 6, that goes in for the h and the k. Remember, the vertex is h comma k. So we're going to put that in, and so we get y equal to a times x minus 5 squared plus 6. That's what the vertex gives us. Now, we still don't know what that a is. Is the a positive? Is the a negative? We can get that information from this 4 comma 8. We're going to find the equation by putting in 4 for x and 8 for y. So I'm going to use x equals 4, y equals 8. This is the vertex. We want this one that's not the vertex to substitute that in, and then we'll solve. Let's put in 8 for y equals a times, our x is 4, so 4 minus 5 squared plus 6. Now we've got a lot of information here. We can do 4 minus 5 is -1. If you square it, you get a +1. So we get, let's subtract 6 from both sides also. So subtract the 6, you get a 2 over here. And then a times -1 squared. Well, -1 squared is equal to +1, so 2 equals just a. So we solve for a. We now can come up with the equation. If we put that back in, we're going to have y equals our a, which is 2, times x minus the x value at the vertex, x minus 5, squared, plus the k, which is the 6. There's my equation given the vertex at a point on the graph. So we can go ahead and come up with that now that we know this general form for the vertex form of a parabola. So one more time, I'm going to just label that. This is called the vertex form because it tells us that the vertex is hk. It shows up right there. All right, let's do a couple problems just to see what we've got here. So following the pattern, our vertex is going to be the opposite of what's inside the parentheses with the x. The same number is on the outside. So I'm going to graph -4, 1, 2, 3, 4, -3, 1, 2, 3. So there's my vertex. My axis of symmetry is just going to be x equals the x value at the vertex. Okay. Since the number in front, it's not listed, so it's implied to be a 1, so it opens up. And that, so that would be down here. I'll put opens up. And so that's going to mean this is going to be a minimum at y equals that -3. So that's the y value there. Let's do the y-intercept. If you put in x equals 0 into it, what do you get out for y? So if I put in x equals 0 into this, I get 0. Change back here, come on back to where we're at. Okay, so if we put in 0 for x, we get 0 plus 4 is 4. 4 squared is equal to 16. 16 minus 3 is equal to 13. So this is going to be a 13. which is way up off my graph up here. So I'm gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It'll be way up here somewhere, okay, for that. All right, let's go ahead and get a table for this. So if we were to put this on our graphing calculator, get a table, put the vertex right in the middle, -4, -3, and then we'll put it on our calculator. So go to y equals, clear this one off. I'm gonna put in parentheses x plus 4, square that, and then put in -3, and then hit graph. So for this one, see, it goes way off the graph to get up to the y-intercept. But notice I can look at this and look at the table and get a couple other values off of this near -4. So if I'm up here at -4, so -4, I got -5. Okay, so -5 will give me a y value of -2. And -6 will give me a y value. So that's so small. Let's go ahead and redo that just to make it bigger. So I'm going to make my table a little bit bigger here so you can see it. X and y. I've got -4, -3 in the middle. Okay, so I'm going to go with -5. And I had a -2 for that, so it's going to go with -6. -6, I got 1 from that. And then if you go with -3, there's going to be symmetry. That'll be the same as -2 there. And if I go with -2, I'll get the same as the symmetric point up there, which is equal to 1. So let's graph -6. So 1, 2, 3, 4, 5, 6, and 1. -5, -2. And then the symmetric points here. My graph would look like this. All right, so describing all the information, let's go ahead and do domain and range now we have for these. Now what you can get as a standard answer for domain is it's going to be -infinity to infinity because it covers all the x values. But the range, the lowest point it goes to is this y value of -3, that's my minimum. So I'm going to start at -3 and I'm going to go off in the y value to infinity. So my range is going to be -3 to infinity. All right, let's go ahead and do this one. I've got some information here to go ahead and graph this one a little quicker. So let's go ahead and do our vertex, which is still going to be the opposite here, 3, 5. Axis of symmetry is just the x equals the x value there on it. It's the folding line right down the middle. So if I did 1, 2, 3, 1, 2, 3, 4, 5 right there, the axis of symmetry, if I were to draw it, would be the folding line right down the middle here of it. Just like this one would be the folding line right down the middle of my axis of symmetry. Right? If you're asked to draw it, that's what you would draw. The x-intercept, you put in the y-intercept, put in x equals 0. What do you get for y? X equals 0, you get -3 squared is a 9. 9 times -2 is equal to -18. -18 plus 5 is going to be equal to -13. So I have -13 for my y-intercept. Okay, that would be way down here past the graph, somewhere down there. Min or max, well this is a negative value. It opens down. So I'm going to have a maximum value, and the maximum value is going to be at the y value of the vertex, y equals 5. So just put a little note here, it opens down. And that's from it being a negative in front. Okay, so if I were to draw this, I know that the next point over is going to be 2 down. It would look like a parabola like this that would go down really fast because of that number. So there's my parabola. And you could get a table off of your calculator for that one. So what's my domain? Domain is going to be negative infinity to infinity, because it covers all x values. It keeps going wide. But my range, my lowest value goes to negative infinity, but my highest value is at this y value, the max, which is going to be 5, and it actually gets there, so we have a range of negative infinity to 5 included. So we now have some vocabulary and detail to go with our parabolas. So these parabolas in vertex form, we can come up with the vertex, the axis of symmetry, the y-intercept, min or max, and domain and range, and that will describe our quadratic graphs.